Time the topic related to the power flow inside the motor continues, and here we see that we have a 3-phase 15 horsepower motor, 4 pole 60 hertz, and he has given us the RPM induction motor delivers full output power to a load connected to its shaft. So this is actually the mechanical speed at which the motor is rotating. So the windage and friction losses are given, that is 750 watts. So determine the maximum power developed. The first is maximum power developed. What is the meaning of maximum power developed? This means that how much power was converted actually inside the machine, how much maximum power was developed, which later on had friction losses and was given as output power. So if we know the output power, if we know, and let's see, can we calculate the output power? So P out equals to actually 15 horsepower into 746 watts. So this will be actually become 11,190 watts. So this was the output power, and he has given us the friction and windage losses, that is 750 watts. So actually the mechanical power developed at the shaft, or the mechanical power that was converted power, will actually be equals to P converted equals to P mechanical developed equals to P out plus P friction windage, and this and this. So this will actually become 11,940 watts. So this was actually the mechanical power developed. The second part talks about what is the air gap power. Air gap power is actually the power that is calculated. We calculate and we have to subtract the rotor copper losses, and then another formula. So we can calculate this by the formulas, that the synchronous speed is given as 120 F over P. F is electrical frequency, P is number of poles, and we get 1800 RPM. And then we can calculate the slip. We know that it is N synchronous minus N mechanical divided by N synchronous, and the slip that becomes 0.04. And once we have the slip, we can easily calculate the formula for the air gap power, and that is actually equals to the mechanical power divided by 1 minus S. This is through the derivation of the formulas previously discussed, and this will become 12,437.5 watts. And in the part C, what it is saying is that we have to calculate the rotor copper losses. Again, the rotor copper losses are actually the copper losses which are directly proportional. Rotor copper losses are directly proportional to the formula with the air gap power, that is S into P air gap. And what we have S is 0.04 and air gap power is here. So the rotor copper losses will become 497.5 watts. Thank you. I hope it helps.